Hi, my name is Noah, and in this video we will be looking at clips of the microscopic features of the solids used in the separating solutions lab from CHEM 1046. The following three short clips show each of the solids, table salt, black pepper, and sand, before adding distilled water. In these short clips, I have isolated each of the solids used in the separating mixtures lab. This will allow me to visualize their microscopic characteristics prior to adding distilled water. In the first, table salt, most crystals were near uniform and appeared cube-like. The second, Himalayan sea salt from a grinder, has very little uniformity, as during the grinding process the salt crystals would be sheared apart. The rough edges can be visualized here. Finally, sand, which has a variety of different shapes and textures, some of which resemble salt. This table salt crystal is isolated, without any surrounding crystals. It rapidly dissolves once distilled water is applied. As it dissolves, it shrinks until it is no longer visible. At a scale not able to be visualized here, the sodium and chloride ions have fully dissociated. Here we can see a dense cluster of table salt crystals. When the distilled water is added, the process of dissolving can be seen happening quickly, but then soon slows down. By the end, it does not appear that the salt crystals are dissolving any further. This is likely due to the number of crystals packed tightly together. Unlike the individual salt crystal, the water does not have access as readily available due to the close proximity of other crystals. In addition, it may be that the amount of distilled water added is not enough to allow the cluster of salt crystals to fully dissolve. This clip is of the same process as the last, a cluster of table salt crystals being dissolved in distilled water, but at a higher magnification. The visual effects of dissolution were most dramatic in this clip. This is a larger crystal from the ground Himalayan sea salt. After the distilled water is applied, the effects of dissolving are easily visualized, and parts of the crystal can be seen cracking off and disappearing. Some of the motion around the crystal as it dissolves is also much more rapid. I would hypothesize that the increased rate of dissolution may be caused by the inconsistent surface area. Due to the shearing effect caused by grinding, the surface of the salt crystal is very ragged and uneven. There appears to be no symmetry or pattern to the edges, leading to an increased total surface area for the distilled water to contact. In this clip, one of the methods of filtration that was used during the separating mixtures lab is visualized under the microscope. There have been some crystals of table salt added to the mesh, some of which fit through the holes naturally, others were too large. After the distilled water is applied, all of the crystals dissolve and are no longer visible by the end of the clip. Through this visual, we can see how the salt was able to pass filtration while leaving the insoluble particles of the pepper and sand behind. In the main separating solutions lab, an additional method of filtration was used as well, a coffee filter. During microscopic examination of the coffee filter, the structure had no symmetry or measurable pores, and is a mesh of varying width fibers. For the purpose of this video, the visual effects would not have been as useful. When distilled water was added to sand, it caused the least dramatic visual effects of all of the slides. There is no apparent motion anywhere on the slide as I scanned, and the shapes of the particles contained did not change. This is consistent with what would be expected from sand. In the final clip, the ground black pepper is visualized on the slide while distilled water is added. By far, black pepper had the most variability in particle features. During the main separating solutions lab, after the first pass of filtration, the remaining water was dark brown. Although the water contained no visible large particles, the coloration would likely have either been caused by a soluble component attached to the black peppercorns, or when the pepper was ground with the mortar and pestle, some of the particles became so fine that no amount of filtration would sufficiently clear the water of color. Originally in the experiment, I had only planned on one filtration using the steel mesh, but after seeing the results of the black pepper, I decided to do additional filtrations to clear the water as best I could. After 3 filtrations, the water cleared some, but remained very brown. In this visual, some of the more brown particles can be seen leaching a darker color into the surrounding water. This, again, is likely either ultrafine particles or a soluble component attached to the peppercorns. By contrast, the first filtration of the sand resulted in crystal clear water with no signs of visible particles. Thank you for taking the time to watch this video. Hopefully you found some of the visuals here interesting. In conclusion, by using a microscope to visualize the size of particles relative to each other and to the pores of a filter, it becomes much clearer why the results of the separating mixtures lab were as they were. Being able to visualize the dissolution of salt crystals versus the relative inactivity of pepper and sand makes the process much easier to understand at a fundamental level.